You guys are never going to believe what I did. Well, maybe you will. I picked up another cheap oscilloscope. This is from Hantek, and it is the DSO5102P. And it's got some really nice specs. It's 100 megahertz, 1 gigasample per second, 40K record length, rise time of 3.5 nanoseconds, and a time base accuracy of plus or minus 50 parts per million. So it was just dropped off a few minutes ago, and you're going to get to see its first boot up. It's only a 2-channel scope, but that's fine. So you guys are probably wondering, why do I buy these super cheap scopes? Why don't I buy a Tektronix? Well, the reason is I like this cheap stuff because this is the stuff that guys like you and me can get into. The average Joe off the street who's wanting to get into electronics and get themselves a nice little scope. Something like this, which I got from Amazon for like, let me see, what did I pay for it? $256. You know, the equivalent Tektronix scope of this level is going to run you almost $500. So I know you're saying, well, what about the Rigel for another $100? The 1054Z, that's a superior scope. Yeah, it is. But it's another $100. You don't need that to get into electronics for fun. A 2-channel scope like this is going to be fantastic, and it's going to cover all your needs. So let's get a probe on here, and we'll calibrate it, and we'll see what's up. Yes, sir, that definitely needs some calibration. And I see these probes they sent us are the PP80 150-200 probes. You get 2 of them. And just see which ones we got. We got the 150s. Okay. So, where are we at here? 150 megahertz bandwidth on times 10. Input resistance is 10 mega ohms. And at times 10, we're 100 megahertz. Maximum voltage input, 600 volts. I still would not recommend putting 600 volts through this, no matter what, okay? That's just really not a good idea. Oh, let's get our trigger set here. There we go. Now we can calibrate this a little bit better. Okay. That looks pretty good. We can turn our bandwidth limit on. Let's see what kind of acquisition modes we have here. Real time, peak, average, normal, memory depth 4K, 20K, 40K. All right. Well, you know how I have a whole kit of stuff that we use when we take a look at multimeters? Well, I've got something new for us to use when we're taking a look at scopes. It's this Velleman board. So let's have a look at it, and then we'll put it through the paces with this scope. All right. So here is our little Velleman scope board. It is a 9-volt AC input, and you see here we have all of these little test points all over here. You see here we have a half wave rectification, full wave rectification. Same thing there. We've got an adjustable sine wave down here. We've got a square wave here. We got a square wave here. Let's hook up here and see what happens. All right. So I'm guessing these are our ground posts down here. And we'll hook up to our first test point here. Roll up to the scope and have a look at what she's got. All right. All right, all right. So, all right, there's our first one. Looks like we have a little, almost a little bit of like a capacitance there, but not quite. Let's take a look at our rectification. Ooh, ooh. That's supposed to be our full wave rectification. Let's see, half wave. Okay, there's half wave. Not bad. A full wave, man, that is just UGLY ugly. It ain't got no alibi. That does not look like full wave rectification. That looks like severe ugliness. All right, test point 3. This should be our, wow, that's supposed to be our adjustable sine wave. Holy smokes, man. All right, man, maybe I got the ground on the wrong spot on the board. Let's try that again. There we go. All right, let's go back up. That's our full wave rectification point. I'm not seeing any difference whatsoever between, that's supposed to be half wave rectification, full wave. Huh. Let me move that ground spot again. All right, half wave, full wave. Oy vey. That's some severe ugliness. All right, this one says DC. Okay. Let's see if we can get a measurement here. Hoo-dee-doo. Interesting. One moment. All right. So we're seeing 14.4 volt max, 13.2 minimum. That's giving us a peak to peak of 1.4 volts. Our RMS is 13.6. All right, I'm going to switch down to the first voltage divider here. Okay, now our RMS is 9. And then the end of the voltage divider, RMS is 4. Okay. All right, so we should have a square wave here. Well, that's not exactly a square wave, is it? And I can adjust it, I think. A little bit. And then the other side. Let's look at that board again. So this is what we've got. There's switching between our single diode for half wave rectification or our 4 diodes for a full rectification. There's our sine wave down here. Then we have a voltage divider. And then we have our square waves over here. I'll tell you what, let's switch back to this sine wave. And we'll go back to the scope. Not a bad looking sine wave. Let's see if we can adjust. Okay, we can adjust the amplitude, but there's no frequency adjust. And if we come back down here and look at the board once again, as you can see, this is coming off of the 9 volts AC, so we're just getting that little 60 hertz input. Let's see what kind of FFT this little guy has. Come on. There we go. There's our FFT, channel 1. A handy window. All right. Doesn't give me a lot here. Let's see, display, persistency, contrast, real time. 1 moment, please. All right, put our cursors on here. That first one on there. 1.54 kilohertz. Interesting. Select our other cursor, maybe. There we go. So this should be the first harmonic. 20 hertz. I don't know. I'll have to do some more reading on the FFT on this. As of right now, it's just not not spectacular. There we go. Interesting. Let's bring in a different signal. What do you say to that? All right, now we're looking at a 60 kilohertz square wave. Not bad. Let's take it up here. There's 151 kilohertz. All right, that's as high as I can go with that. Let's slow her down. See what we get. And we're down to 21 kilohertz. Now we're down to, what, 6.7 kilohertz. Take her way down. .855 hertz. 383 hertz. Keep going. How low can you go, right? There's 74 hertz. There's 1 hertz. Let's see. Yeah. Very good. It can go down and read as low as 1 hertz. That's pretty awesome. Let's take it up. Let's go to, say, like 100 hertz. All right, 130. 130. Let's adjust our duty cycle. There's a 1% duty cycle. And if we bring up our measurement, Let's we can adjust these here. Take that rise time. I don't like that one. Alright, I forget how to adjust these. There we go. We'll make that pulse width. No, I don't want pulse width. I want a duty cycle. Paul, you're dumb sometimes. Where's duty cycle? There we go. So that's showing us 1.09, so that's pretty doggone good. Let's take it up. There's a 99% duty cycle, and again, she is right on the money. So far, and you know, mind you, we've only been playing with this for what, about 15-20 minutes. I like what it has to offer. So far, the only downside I really see is the FFT wasn't super spectacular. Yeah. I don't know how much I like that. But, you know, in a $250 scope, well, that's better. You're not going to get a whole lot of fantastic spectrum analyzer performance. You know, it's just not something that they can throw into a low-cost scope like this. All right, now we are looking at the output of one of the crystals in Arduino. This is the 16 megahertz crystal, and you can see we've got these. I like how Hantek puts these really nice measurements down here. We got our frequency of 16 megahertz, our period, our RMS. We can hit our measurement button again, and we can bring all that stuff up there like that. That works out really nice. Let's see if we can pick up any other signals off this here Arduino. There's another clock, another 16 megahertz clock. Nothing there. What we got going on there? What we got here? Yeah, that's about all off the old Arduino, but the scope is picking things up really nice. Again, for a low-cost beginner's home play around with oscilloscope, I'm liking it. Okay, so in the package we got our two PP150 probes, a USB cable, and with the probes you get all your little rings, the cover, and the non-conductive adjustment tool. We get official Hantek certification. We get a mini disc that has the manual and the software on it. A warranty card in Chinese and in English. Not so much in English. A little bit of English. And we get a packing list. So that's what you get for your 250 bucks on the Hantek DSO5102P, 100 megahertz, 1 gigasample per second. Beginner's oscilloscope. Not bad. Hope you guys enjoyed this little oscilloscope video. If you did, give me a thumbs up. Feel free to comment and share, and don't forget to subscribe. Big thanks to the patrons. It was Patreon money that allows us to buy things like this. So if you're not a patron, why don't you consider becoming one? All I ask is $1 a month. Alright, that's it. I'm out. Peace.